So the last chapter dealt with a method of inferential statistics that we call estimation, in which we construct confidence intervals about a population parameter. Now we're going to look at a different type of inference called hypothesis testing. There are a lot of different hypothesis tests that exist out there. In this chapter, we're going to be doing hypothesis tests regarding a single population parameter. And the two parameters that we're going to be working on are the population proportion and the population mean. So to give you a feel for what hypothesis testing is all about, I'm just going to go through this scenario here. Suppose for each student in a class, I say I'm going to flip a coin. And if the coin comes up heads, your grade in the class is earned based on the syllabus. However, if the coin comes up tails, you automatically earn an A. So certainly you're rooting for a tail when the coin's on you. So let's say that the first 5 students all ended up with a head. So the first student I flipped head, second student head, third student head, fourth student head, fifth student head. And the question I asked of you is, if you saw 5 heads in a row, what might you conclude?
It was rigged.
That it was rigged. So now you are, Scott, in the position of accusing your instructor of cheating you.
Well, if you look at it, because you have the 50% chance each time, right?
Right.
And then it just all happens to come up heads.
Right.
I guess from my first inference would be that it would be swayed in some way that it was in your favor to have them all turn heads.
Okay, and so I'm going to bring in some formal language here. Well, I'm not even going to have to bring in formal language. I'm just going to say that when somebody brings a coin to a game, you would assume that the coin is what we call fair, meaning
Right.
half the time you're going to get heads and half of the time you're going to get tails. This evidence that we're seeing right here of 5 heads in a row feels like that would be unusual under the assumption that the coin is fair. And so what you are implying is that the probability of getting 5 heads given a fair coin is a low probability, right? Mm-hmm. And in fact, we can compute this because we're assuming the probability of getting a head is 1/2 or 0.5. And flipping a coin from one time to another is an independent event. So the probability of getting 5 heads is the probability of getting a head times the probability of getting a head times the probability of getting a head times the probability of getting a head, and then lastly times the probability of getting a head. And so we're multiplying 0.5 times itself 5 times, which is like raising it to the 5th power. And if we do this computation, we get 0.03125. So if the coin is fair, it is possible to get 5 heads in a row. It's just that you would only observe that about 3 of every 100 times you conducted this experiment. Mm-hmm. Right?
Yeah. Right.
And so that is why your intuition suggested to you, wow, maybe this game is rigged against me because of the fact that I just observed something that is highly unusual under the assumption the coin is fair.
I have a quick question.
Yes.
Is there does that rule like 0.05 come into play then, where like it'll like, instead of it being unusual, now it's like sometimes, is there like a level to it? That makes sense?
there is a level, and you kind of intuitively figured out that the probability of getting 5 heads in a row is very, very low,
Right.
making it an unusual result. And in fact, yes, getting 5 heads in a row is unusual using that cutoff of 0.05 that we introduced earlier in the course.
Okay.
Right.
Mm-hmm.
But here's the thing. There's one of two possibilities here. Possibility number one is the coin really is fair and we just happen to get 5 heads in a row. In other words, all those students were unlucky. The second possibility is what Scott implied me of, and that is that the coin is not fair and is somehow more weighted towards getting ahead. Maybe it's a two-sided coin where both sides are heads, and you're willing to accuse the instructor of rigging the game against the students. So that's the question that you have to ask yourself here. Are you willing to accuse your instructor of using a coin that is not fair, right? That is biased towards flipping heads. The only way you would know the answer to that question is, one, requiring the instructor to share the coin and seeing if one side's heads and one side's tails. But then you could keep flipping the coin over and over again and keep track of the proportion of heads that you observe, even if one side is heads and one side's tails, to get a better sense of whether or not it's weighted against you. Yeah, barring the instructor willing to share the coin with you, you're never really going to know whether the coin is fair and just happen to come up 5 heads in a row, or the coin is not fair. And that is the heart of what we call hypothesis testing. We make an assumption about reality. In this case, the coin is fair and the probability of getting a head is 0.5. And then we collect sample evidence and judge whether or not that sample evidence is consistent with our assumption, right? Like here in this scenario up here, getting 5 heads in a row is not all that consistent with a fair coin. And that's why you were willing to accuse the instructor of not using a fair coin.
Right.
And so that's the process that we're going to go through for all of hypothesis testing. Make assumption about reality, collect evidence, and weigh that evidence against our assumption. And if the evidence is not consistent with our assumption, we're going to say, maybe my assumption was inaccurate. Now we're going to formalize that process, but that's the basic gist of it for the rest of our discussion of hypothesis testing.